4.6 limits at infinity. All right, so using our notation, lim as x approaches infinity or negative infinity of some function, if that equals finite value L, then that's called a limit at infinity. And it will also correspond to a horizontal asymptote for the function f. And we will also describe the right end behavior of the graph of f. Right. So if you have the limit as x approaches negative infinity, i.e. x is going very far out to the left without bound, and that approaches some finite value again, then you still have a horizontal asymptote for f, but now you've described the left end behavior of the function. So let's take a quick example. Very important function to be aware of. We'll graph the tan inverse function. F of x equals tan inverse of x. All right, so we'll call this pi on 2, and symmetrically down here, negative pi on 2. It turns out that those are horizontal asymptotes for the tan inverse function. And the graph looks something like this. Well, it's good enough for our purposes. Okay. So certainly here, the limit as x approaches infinity, i.e. x is going out this way, further and further and further, farther and farther and farther, the function tan inverse of x, clearly the function, as x gets larger and larger, the function is getting closer and closer, right? Always a little bit closer, but never going to come in contact with, but it is heading towards the pi on 2 height. So that is, as you see in the picture, a horizontal asymptote for the tan inverse function and does describe the right end behavior simultaneously. Okay. Oops. Limit of tan inverse as x approaches negative infinity is then negative pi on 2. Should be pretty clear from the picture now. Right? As x goes very far out to the left, right, towards negative infinity, meaning further and further and further, farther and farther and farther, and the function glides down these values, heading closer and closer and closer. Right? As close as you can possibly imagine without ever coming in contact with, but certainly is heading towards a height of negative pi on 2. So therefore that is a horizontal asymptote for the tan inverse and simultaneously describes the left end behavior of the function.